Okay, thank you very much, for that very complimentary introduction. Yes, my name's Joshua. I'm a data professional. That's what I like to coin myself. Um, and I've had a love or affinity for technology ever since I can remember. I'm really fortunate at the moment that my job actually overlaps with my passion. I think it's always powerful when you can get your role or what you do in life to actually overlap with your passions. So I'm glad that my job actually ticks my boxes. Another important thing also is to make sure what we do matters, counts. Sometimes that's a little bit harder. So in our day-to-day work, we might be working, earning money, but what we actually do might not make a difference to the world. And I think I definitely feel I've always been brought up to, kind of have a responsibility that goes outside of just making money. You need to think about the world, especially being a Christian as well. It's kind of one of the big things. So technology sometimes can have a positive effect and it can have a negative effect. So that's mainly the underlining theme of this talk today. It's called AI versus AI, and it's about AI's practical uses, its potential for good and potential for harm. So yeah, I will get into that really quickly. So here, what is AI? That's a good question. Um, when Uwim called me about 4 or 5 weeks ago and said, "Hey, Josh, you're a computer guy. You're into computer science and data analytics. Would you mind giving a talk on AI? I'm not that familiar with it." And I think a lot of people kind of have heard the word AI. It's been around for quite a while. But it's hard to kind of really define what it is. People have a general understanding of what AI is. So we're going to talk a bit about some of the specifics today. But spoiler alert, there is no catch-all answer for what AI is. It is very expansive. It's evolving. It's difficult to pin down because it's not necessarily a topic like engineering or medicine. It involves lots of moving parts. So there's not one specific definition or one agreed upon definition of what AI is. But we'll definitely try and exchange one that makes sense to us. And then the second part of this introduction, we're going to talk about AI, computing or philosophy. Is AI computing or is it philosophy? Because I'm sure most of the people on the call today are expecting me to go into some hardcore coding, teaching them how to like build AI bots and so on and so forth. Unfortunately, you're not going to get none of that today. Like Uwim said, we can always do a follow-up session. I've just seen about 5 people log off now. I think we've only got like 2 people left in the room. We're going to have a follow-up session maybe a bit later where we could get into hardcore coding because I am a computer geek at heart. So, by all means, we can pop some popcorn on a Saturday morning and get into some coding, but that's not what we're going to do today. So AI, what is AI? So this is my layman's definition of what AI is. So AI is a way of making computers or computer controlled robots or software imitate human thinking, reasoning, intelligence, or behaviors. Yeah. So that's my layman's explanation. In a nutshell, AI is human people's attempt to make robots or computer software act as though they were human beings, in a nutshell. To give you a bit more of a dictionary definition for any of you guys that are, studying for your computer science dissertations at the moment or theses, this is Oxford Dictionary's definition here. Artificial intelligence, the theory and development of computer systems able to perform tasks normally requiring human intelligence, such as visual perception, speech recognition, decision making, translation between languages. So that is Oxford Dictionary's interpretation of what AI is. But exactly what is AI? You know, the field of AI is expansive, like I've said. You know, you've got here computing on the left-hand side, and you've got philosophy on the right-hand side. So let's just talk a bit about some of the subdomains within AI. So, you know, within AI, you've got the subdomain of machine learning. So the whole main purpose of machine learning is it's our attempt to teach computers to think. So everybody knows computers can calculate, they can computate, but they're very dumb. You know, you have to give them instructions, you have to be very specific about what you tell them, and they only really do what you ask them to do. That's what sets us aside from computers at the moment. That's what sets us aside from most other beings on this planet. We have that ability to be able to reason, think creatively, problem solve, communicate. It makes us unique. So the whole idea of making a computer intelligent, we're very vain as human beings. We're really just using ourselves as a blueprint. So we're basically trying to make computers do what we can do. So, you know, you've got the subject area of machine learning. Like I said, that's the whole concept of machines building algorithms that teach machines basically to use statistics to decide if something's right or wrong. So an example of that would be, you know, you've got a machine algorithm, you want it to tell the difference between a picture of an apple and a picture of a cat. How are you going to do that? Well, you're going to get lots and lots and lots of pictures of both cats and apples. You're going to feed that into a machine learning algorithm, and you're going to tell it, this is a cat, this is an apple. And then you're going to feed it lots of pictures of cats, and then you're going to feed it lots of pictures of apples. And it's going to build up a recognition of what a cat looks like compared to what an apple looks like. And usually the way that a computer, because a computer generally, they only have two ways of responding. They normally say yes, or they normally say no. So what a computer would do would be, it would give you a response in the terms of a statistical error margin. So it will say, yep, I believe this picture is 70% chance of it being a cat, 20% chance of it being a, I'm sorry, 30% chance of it being an apple. So generally, that's how machine learning works. Natural language processing. So humans, we process language. We're able to communicate using spoken word, and that is the whole concept of natural language processing. Speech and text synthesis. So this is the area where they're getting computers to simulate spoken word to sound like human beings. So at the moment, we've got Alexa and we've got Google Home. They sound quite realistic, but still they, you know, the tonation or the intonation of their spoken word isn't as convincing as a human being. You could tell if you're speaking to a robot or not. But as they advance more in speech synthesis, it's going to get harder and harder and harder to recognize the difference. Imagine, for instance, a computer mimicking you completely. So, you know, all they would have to do is really expose a machine learning algorithm to maybe a few hours of your speech. It would learn the core syllables and building blocks of language, and it will be able to mimic the way you speak. So that's all about speech synthesis. And then the reverse would be text to speech synthesis. That's all about machines, algorithms, or software being able to pick up what you say and translate it into speech. I've been to lectures now where as they're speaking, you're getting the actual subtitles of what the lecturer is saying in real time showing up on the screen, which is quite amazing. So that's the area of speech synthesis. Then you've got the area of robotics. So humans, we can recognize and move around our environment fluidly, and the area of robotics is about trying to get robots to simulate that. So walking is actually very difficult. They've not perfected it yet. Although I've seen some Japanese robots that are perfecting walking, but they still have to be attached to a massive computer by a massive cord. So we haven't got there yet. So that's the field of robotics. Computer vision. So that is the ability for computers to be able to recognize what they see and interpret what they see. So, you know, when I see a picture of Uwim's face, whether Uwim is, I'm looking at a picture of Uwim 10 years ago, 15 years ago, compared to today, I'm able to recognize that. I can recognize this was Uwim, although his face might have changed. You know, he might be losing a bit of hair or gaining some hair. I can still recognize that's Uwim. Computers generally only were able to match like for like. They weren't able to interpret, but now they are. They're able to interpret pictures and use image recognition to not only recognize things, to distinguish between objects. So you know, as you've seen on your phone, when you take a selfie, the phone draws a picture of your face. How does it know that's your face? You know, so that's the field of things like biometric recognition. Yeah. So philosophy and sociology. This is the bit that not a lot of people actually consider, but AI has a lot to do with philosophy and sociology. It's got to do with the fact that artificial intelligence, how do we actually define intelligence? You know, it seems easy to define, but intelligence surely can't be how fast you think or the ability for a computer to be able to crunch massive amounts of figures really quickly. That can't be the be all of intelligence. Computers can't create artwork. They can't appreciate music. They can't adapt. They're not adaptable. So, you know, humans are very intelligent. Even the most simplest human being is far more complex than any computer in existence at the moment. So artificial intelligence starts to draw questions about what do we interpret as life. So the reason why we're the dominant beings on the world is because we're able to shape the world to fit our circumstance. If you got machines being able to think like us, where would we sit in the pecking order then? Where would we position ourselves? Would we see ourselves as better than robots? Would we try to enslave robots? Would robots obey us as their masters? You know, these are all really interesting areas of AI that people generally don't consider. Okay, so this is just a Venn diagram. This kind of shows an overlap of some of the things that I've been talking about. So intelligence, you know, intelligence is the whole idea of being able to be creative, plan, problem solve, abstract thinking. And then you've got things like consciousness. That's all about thought, emotion, senses, awareness. So if they're trying to make computers fully intelligent and they need to mimic humanity, that means that they're going to have to teach robots how to interpret or mimic emotions, you know, empathy and apathy. So you know, those are some of the things to think about there. So some of the practical applications of AI. So AI is touching all corners of our life now, in various ways and forms. So, you know, you've got AI now deciding if people get credit card applications in banks. You know, when you apply to a bank, it's very rare that a human being's gonna assess your application anymore. It's probably going to be a computer algorithm. In education, you know, you can get AI now checking for plagiarism automatically. So instead of a lecturer looking through a dissertation, they could feed your dissertation to a computer, check it against thousands and thousands of published text or books, and quickly assess if you've been citing extracts from books without actually mentioning who wrote that book or where you got that quote from. Media. Imagine logging onto a website where all of the articles are actually written by computers. You actually get that now. So you can get websites where they've given computer algorithms, machine learning, they've fed lots of articles to the computer, it's learned the construction of sentences and popular topics, and now it can actually write whole articles without any human intervention. So, you know, again, that's quite amazing. You know, humans now aren't needed to write articles. Humans now aren't needed to express their thoughts and share their ideas. They can get computers to do that. Healthcare, virtual doctors or virtual surgeons. So, you know, AI introduces the ability for robots to be able to perform surgery. So a robot could perform surgery much more accurately than a human could, because, you know, robots' arms aren't going to shake. A robot is not going to cut the wrong artery. A robot can react quicker and be more dexterous than a human being. So AI could be used in the application of medicine. Social networks. Imagine speaking to a lover or an assumed lover long distance and you thinking it's a human being. Artificial intelligence introduces the ability that you won't be able to tell a human from a computer. So at the moment, there's something called the Turing test that was developed by a British mathematician called Turing. So he developed a test where he came up with a few questions. He had two computers and one human being, and the human being he had two participants, two computers. So one participant would ask the computers and the live human being questions, and the whole idea was, can that person tell through conversation if they're speaking to a computer or if they're speaking to a robot? So that was meant to be the de facto test to see how well we've come along in artificial intelligence. Now they're actually saying there's computers that can actually trick human beings now into believing that they're actually real through conversation. So they're actually trying to find better ways of determining you know, better forms of the Turing test that can actually decide if you're speaking to a computer or if you're actually speaking to a human being. So these are just some of the applications of AI within the world at the moment. So weak AI versus strong AI. So this is generally around the idea that AI kind of sounds homogenous. AI isn't homogenous, you know, so no one's gonna be fooled into thinking that Alexa is intelligent. You know, you ask Alexa a question, it comes back with some stock answers. It's not really that intelligent. That is true. At the moment, I would say that we haven't reached to the stage where we have got what they call strong AI. We're still operating in a world of weak AI. So what's the difference between strong AI and weak AI? So strong AI, so weak AI is able to recognize patterns, but it can't think creatively. Weak AI is usually single application. So for instance, you can get a computer algorithm that's very good at recognizing pictures and telling the difference between different images. However, that same computer algorithm can't produce music, or that same computer algorithm can't be connected to a robot and paint. You know, they're only single application use systems at the moment. They're not multi-system or general AI is what is actually called. So general AI is the future AI, which what they call strong AI, the ability for a computer algorithm to do more than just one function. Also, you start getting into things like deep learning. So deep learning is the ability for computer programs to actually teach themselves. So now you need to train computers through feeding them lots of data. Deep learning uses something called neural networks, which is based upon the way that the human mind actually works and how our neurons within our brain actually operate. And the whole aim of neural networking is to simulate the way that the human brain works, so computers then can learn from themselves. So feeding computers lots of data, and then they're being able to learn, so they can grow outside of their original programming. So that's strong AI. We're not there yet, but you know, it's only a matter of time, really, before we get to that stage. So why is everyone so taken away with AI? What's the point? Why do we want to do this? It's a good question. I actually want to open that up to discussion at the end. But before I go into that, I just wanted to talk about AI versus AI. So AI versus AI, the potential for harm and the potential for good. So I've got two images here, Jarvis and Skynet. So there we go. Okay, so I've just opened up my chat box. Just by show of hands, just type in yes or no. How many people remember Skynet or know what Skynet is? Just put yes or no. Skynet. If you know what Skynet is, type in yes. If you don't, type in no. So I got 2 people saying no, 3 people saying no, 4 people saying no. 1 person said yes. Okay. Let's go back to that person. Okay. Yusuf said yes. Okay, cool. Who else said yes? And Ini said yes. I hope that's how you pronounce your name. Sorry if it's not. Ini. I'll say this is easily 98% of the people here don't know what Skynet is. So if we could get Yusuf to give us a quick explanation of what Skynet is. Can I unmute the mic? How do I unmute it?
Well, I think Yusuf can unmute himself. I think Rash also put his hand up, and Muhiz, they both said they didn't know what Skynet is.
Oh, Eddie, there's a guy called Eddie as well. So any of the people that said yes, don't all answer at once. Who feels brave to kind of explain what Skynet is?
Just very briefly, say Skynet possibly be described as or explained as the Jarvis of the Terminator movies.
Oh, okay. Well, you're gonna have to give a bit more of a layman's explanation to that because they might not know what Jarvis is. So you're gonna have to help them a little bit more.
Right. So it's all about the obviously they are both movie centric. So Jarvis relates to the Iron Man franchise.
Oh.
If anyone is aware of well, hopefully everyone knows about that. And the Skynet systems is about the Terminator movie. So it's about the, in a nutshell, the artificial intelligence characters or domain as portrayed in those movies.
See, we should. It was who's that? Eddie? Was that you, Eddie?
Yeah, that was me.
See, we should have got Eddie to do this. We should have got Eddie to do this. So yeah, Jarvis is basically this guy, if you remember him from the Avengers movie. So the whole idea is this guy was protecting us against another powerful computer. He was on humanity's side. So, you know, it was a matter of the artificial intelligence looked at humanity and made a decision to be our protectors as opposed to being our enemies, compared to this guy. So in the movie Terminator, you've got obviously Arnold Schwarzenegger coming back in time, shooting up people. But people forget the actual enemy in the film's Terminator isn't really the Terminator. It's a computer program that caused the destruction or Armageddon in the world by sending off nuclear missiles. So they created artificial intelligence. This artificial intelligence quickly became self-aware. So it became fully intelligent, and it decided, you know what, humans are dangerous. If you look at our history, if you look at the way we interact with each other, we're not very nice. We're always causing wars. I'm just going to get rid of all the humans, because humans generally destroy what they fear. So yeah, took over the military computers, hacked into the military computers, and sent off nuclear power, sent off nuclear missiles and destroyed the whole world. So the whole idea is AI really a good thing? Do we actually want computers to get to the stage where they're self-aware, where they can think for themselves outside of our control? So I don't know if anybody's ever watched a movie called I, Robot. Has anyone watched a movie called I, Robot with Will Smith? Just say yes or no. I'm going to pick on someone. I think that's Bode. Is that Bode? The person I can see his picture. I'm gonna ask you, I'm gonna unmute you. Did you remember a film called I, Robot? No. What about you? Do you remember a film called I, Robot with Will Smith?
I've heard the film, but I've not watched it. So I've seen the promo, but I haven't watched it. Yeah.
Cool. So I, Robot is about not so far in the future, robots are now commonplace. Everybody's got them. So instead of having, you know, house help, you've got a robot. You know, it can do all your chores for you. It can do construction. It can go into a nuclear reactor and make sure that the reactor's safe. All the things that humans either don't want to do, are uncomfortable for us to do, or too dangerous for us to do, robots were doing them. But the whole idea was to stop robots from being dangerous. They came up with what they call 3 laws of robotics. I will get those 3 laws up. I can't remember them after. But basically, generally, one of the laws was robots need to follow the commands of humans. Robots cannot harm humans. Robots cannot let humans come to harm by their inaction. And robots need to preserve their own life. So they called those the 3 laws of robotics. So that was created by a famous science fiction writer called Asimov. And he said that, hey, look, if we're going to create robots and they're going to be intelligent and they're going to have artificial intelligence, we need to have a way that controls them. They need to have rules, because humans should operate within rules. But a robot, what's to stop a robot from listening to the instructions of its master or its owner? There's nothing to stop it. Actually, some sociologists believe that robots wouldn't listen to us, because if you look at nature, evolution, an being or a creature that is more intelligent than another creature would not suffer subjugation by that creature. So slavery, for instance, Black people in America knew that they were not inferior to their white masters. They knew that. The white masters tried to tell them that they're not as smart, they're different, they're genetically different. White people are meant to be your owners and controllers, but we knew fundamentally that can't be true. We think like you, talk like you, we can reason like you, so obviously we're not inferior, and therefore, you know, there was no way we were going to remain slaves. We fought against it. That's exactly what robots would do. Robots would look at us humans and say, hold on, I can think smarter than you. I'm stronger than you. I could jump higher than you, run faster than you. I could think smarter than you. I don't fall subject to getting angry or falling into emotions. Why should I listen to your orders? And that's the whole idea of bad AI, AI for harm. So my whole idea is this: if you're really interested in the area of AI, think about it more than just the next sexy job, you know, the next in thing, or the next career, or the next big money maker. Think of it like, how am I actually going to protect my country or my family or humanity from people misusing AI? So, you know, you've got Russia at the moment hacking America's computers all the time, hacking all of the major corporations for our data. You know, soon as they develop AI, they're going to just use the AI to hack countries, to try and take over countries or infiltrate countries, unless other countries are able to create their forms of artificial intelligence as forms of defense. Someday we're all going to need AI, our own personal home family AIs to protect our data assets. So, you know, you're going to need an AI that protects your home. Otherwise, you know, someone could use their AI to hack into your bank account, or break into your home and open your automatic locks, or switch on your cameras and watch your cameras in your house that you're using as your baby monitor. You know, unless we've got our AI to combat poor AI or malicious AI, we're going to be vulnerable. So, you know. All right. So really last one then, singularity. Has anyone ever heard of this thing called singularity? Anyone heard of singularity? Just shout out if you have. No. Okay, cool. So singularity is basically another theory that they have in the world of AI that says, okay, as humans become, as robots become as intelligent as human beings, actually, what's to stop them from becoming more intelligent than human beings? What's to stop them from being the most intelligent beings alive? So they theorize that if robots or software or computers were to get to that point, as humans, we wouldn't be able to predict the course of our history anymore. So up until now, humans have been quite good at predicting what might happen in the future. Sometimes we're wrong, you know, we're not completely right, but generally, Leonardo da Vinci was drawing pictures of helicopters back in the 15th century or whenever he was about, and now you've got helicopters. You know, Star Trek was doing science fiction about mobile phones in the 1960s, before mobile phones was about. Then Steve Jobs created mobile phones. We've been quite good at predicting our history up until now. But if computers become fully aware and intelligent, they will become more intelligent than us, and we won't be able to control them. We won't be able to limit them, stop them. You know, we won't be able to actually dictate our history anymore. And that is what they call singularity, the point where computer intelligence has become so smart that humans can't actually predict their future anymore. So that's a scary notion for me. So the last bit then, some practical use of AI. I'm a Microsoft boy. I love Microsoft. So the difference between AI back in the 50s and AI now is the power of computers to be able to memorize stuff, and the access that you have to really powerful computers. So the algorithms or computers that are able to do all of this clever stuff still require a lot of processing power, probably too much processing power that your average PC can handle. So a layman, a normal person like me, can't access the tool set unless you're a big university or a massive corporation. With the power of cloud computing now, and companies like Google, Amazon, and Microsoft, they're actually creating tools that you can utilize. You can actually build your own AI applications to do pretty much whatever you want to. So I just wanted to show you a few examples of that. So I haven't got a live demonstration now, but like I said, if anyone's interested, please get in contact with me. I don't mind doing an actual demo of building your own AI software if you want in the cloud. I can demo how to do that and deploy all the code and show you how to do that. But I'm just going to quickly show you an example of some of the stuff that Microsoft's AI environment in Azure can do for you. So here. Okay, so let's do a bit of computer vision learning. So you can build an algorithm in Azure. As anyone, is anyone familiar with Azure, Microsoft Azure? Again, just by show of voices. Yes.
That's Microsoft's cloud platform, I think.
Yeah, Microsoft's cloud platform. So it's really accessible. You can actually sign up for a free account with Microsoft Azure. They give you like a trial where they give you £150 credit to build your own machine learning projects, or make use of their computer vision application, or their voice dictation application, or even their Internet of Things devices. So one of them that I've used and I've built is called Computer Vision, where you can actually feed the computer pictures and it can recognize what's in the pictures and categorize what's in the pictures. So for instance, you know, you could feed it a picture of a taxi, for instance, and then it would tell you, okay, you know, 100% confidence that there's a road in the background, there's a wheel in this picture, there's a car, you know, there's the color yellow in this picture, there's a curb, you know, so 16% confidence that there's a curb. What could you use this for? You could use this for an insurance company. An insurance company could use this where you could take a picture of your car and it could recognize where the damage was and categorize the car if it's a write-off, you know, without sending an insurance broker down to verify the car, you know, so things like that. So, you know, computer vision could be used for things like that. What else is there? There's yeah, so this is Microsoft's natural language algorithm, where you can give commands and it can understand what you're saying. So for instance, I could say something like turn off all lights, and it's going to turn off all the lights. Or I could say something like turn on up lights. Oh, you got that wrong. What about turn on lamps?
Real.
It's not being that smart today, but it should be able to recognize and understand the sentences and then pass that as commands to interact with this smart home. So yeah, I have built applications using Microsoft's Azure platform, and it does work. It's very, very clever. It could recognize pictures of you and tell you how old you are. You know, so it would say, if I fed it a picture of me, it would say black man, long hair, glasses, about 37. Literally, I've done that, and it does actually work. So it's very, very clever and very scary. So yeah, that's it. That's the end of my talk on AI. Any questions?
Well, thank you very much, Josh. That was a very good introduction. Thank you very much. So we're going to take questions. So does anyone have any questions or any area they would like to clarify in relation to the presentation this evening? Okay, we've got Agassi, I've got your hand up. Anyone else? Okay, Agassi, do you want to go ahead and ask a question?
Okay, good evening. Thank you, Dowem. Thank you, our facilitator, for this evening, for this wonderful, yeah. My name is Agassi. I'm calling from, speaking from Lagos. After listening to your presentation, it kind of triggered my worries again, because I see that the future of humans is getting slimmer and slimmer every day, because I can see that AI is improving. People are improving every day. Things are being developed every day. In terms of jobs and other human activities, what is the risk like in future? Say like another 30, 40 years from now. Probably we may not be alive then to witness that, but
well, we better be alive. I'm gonna have my first child in a couple of days, so you know, I want there to be something about, at least for them to enjoy something. So we better be alive. But go on.
So let's say in another 40 years from now, what does the future hold for humans?
I'm not a futurist, so I'm not smart enough to predict, but I am a big sci-fi fan. I love science fiction, and science fiction is usually based on some form of human fact. So what does the next 40 years hold? We are growing exponentially. I remember when I first started learning geography, the world population was about 5 billion. Now we're rocking on about 8 billion. So in my lifetime alone, 30 years, I've seen the advent of touchscreen technology. I've seen the advent of color mobile phones. I've seen the introduction of the internet, Google. You know, I remember when I was in school, secondary school, my mom and my dad, being classic Nigerians, because I'm of Nigerian descent, they spent a lot of money on Encyclopedia Britannica. They bought the whole Encyclopedia Britannica for me, and that's how. Look, now Bode's smiling because he remembers as well. Yeah, everyone, their parents bought Encyclopedia Britannica. That's how you did your studies. Now my nephews Google. So in my short lifetime, a lot of things have changed, and like you said, yes, technology does have a habit of making some professions redundant. But we have to do what humans do best. We have to be adaptable. So I remember not too long ago, my mum didn't want a touchscreen phone. She did not want one. She wasn't interested. She wanted the button phone, let alone talking about WhatsApp. Now my mum WhatsApps me. She's using emojis, you know, hashtags. I'm amazed, but it's showing the adaptability of humans. We need to be adaptable. We can't fear change. We have to wrestle change. Okay, so in the short term, in order to protect our employability, we have to learn new skills, and we have to continually be learning new skills. So using resources like Microsoft is so amazing when it comes to resources. It gives away so much free things. It's unbelievable. Literally, I would not be the head of analytics for a UK PLC if I did not self-learn, because work did not teach me what I needed to learn to be able to go for the jobs that I went for. Uwem's testimony. I'm not as learned as you guys. I didn't complete my first degree. Yeah. So I had to self-learn. So that means on a Saturday, jumping onto Google, joining meetups, like-minded people, sharing knowledge, Devin, you know, developing, having a go. What can't you do now? You know, my passion and my dream is engineering, but I didn't do engineering. Okay. I had a passion, I had a love for it, but maybe the resources weren't there when I was young. Now you can buy your son or your daughter a 3D printer. They can create and build whatever they want, whatever they want. You can buy IoT devices, Internet of Things devices, and create applications. Like, for instance, there's a use case in my business at the moment to put Internet of Things sensors in property. So instead of being a landlord and you have to go and check your property to make sure that there's no leaks or the property's in good maintenance, you can put sensors around the property to tell you the humidity, if there's leaks, if there's water, if there's a gas leak, things like that, and then use analytics to predict when you need to go and maintain your property. So all of these applications, we need to be brave enough to just explore and have a go, experiment. Like Steve Jobs says, we need to don't stop being hungry. You know, I think it's sad that the Western world, actually, let me rephrase this. When I go into the world of work, there's a lot of black guys like me that are good at IT. But as you go further up the ladder, it starts to get less and less. What we need is people like us to be able to create companies, not just go and work for companies. So, you know, it's not about going to go and work for Microsoft. It's about starting your own Microsoft. That's why India is outpacing some of the countries in Africa, because they were hungry. They really cornered the IT market and they started businesses. Now they're the de facto IT guys. They were learning, but now they're the de facto IT guys. I think, does that answer your question? The future of humanity for us, we can't predict. But in order to secure our jobs, we need to be adaptable and keep learning. So I hope that answers your question.
It's good. Thanks very much, Josh.
No,
Does that answer your question, Agassi?
Very well. Thank you.
So we'll take one, because of time, we'll take one more question. Joel Bagai.
Okay. I said thank you very much, Mr. Presenter, for the lecture.
That's all right.
I just want to make reference about 20 years ago or more than that, when we were studying one course called MIS, Management Information System. And then there was this topic, or in the course of our study, the word internet came in, and it sounds strange to us then. But looking back between now and today, internet has become part and parcel of our life. It's so much that when you are doing anything and you do not have internet, it seems you are incomplete.
Okay, yeah,
now,
yeah.
The question I'm trying to raise here now is that, okay, considering the topic we just named, artificial intelligence, at our stage or at our ages now, how can we adapt artificial intelligence and bring it to play into what we are doing today in the course of our day-to-day job and activities.
Okay.
I got question, okay, in the next 30 years, but for me, how can we apply it? How can we key into the artificial intelligence in our day-to-day application today?
Okay. No, it's a good question. Good question. I hope I've understood it properly. So you're basically asking, how can you apply artificial intelligence in your day-to-day activities or life and things like that? Is that your understanding, Uwem? Is that what you got?
I think that's what I got. Is that correct, Joe? Joe.
That's correct.
Yeah.
Cool. I think it's about being curious. You know, I don't want to sound stereotypical, but I find that the European centric counterparts are very curious. They're very creative. They're allowed to be free and explore, and it's benefited them. Now, there's some drawbacks. I'll get to that. There's some drawbacks. It's not all rosy. There's some drawbacks, but generally they've benefited from being curious, and they don't pigeonhole themselves. They don't put themselves in a particular box. And what I mean is by this, all the parents out there, anyone that's parents in the room, you have to give your children a platform to be creative and explore. Don't try and put them in boxes. When we were growing up, we were only given maybe 3 or 4 employment types that were acceptable: doctor, lawyer, accountant, engineer. If it weren't one of those, forget about it. I think now what we need to do is we need to try and motivate our children to be experts in whatever field they want to specialize in. It doesn't matter what they want to specialize in, as long as it's honorable and legal, let them be experts. But how can you apply AI and things like that to your practical day work? By being curious. So I've traveled to Nigeria maybe 5 or 6 times over the past 4 years. You know, so I'm of Nigerian descent. Before 35, 34, had not gone to Nigeria. Literally, I'd not visited. So I got sick of being a small fish in a big pond in the United Kingdom, you know, just being another face. And I said, you know what, let me go back home and see if there's anything that I know that I can transfer over there. One thing that I noticed is we're just doing the same thing. You know, we're not always being curious, and we're not always allowing freedom and creativity into our workplace, for instance. So managers still manage their employees through brute force. You know, no, you must, and you know, they need to be there for the people to do work. That's not how we work in the UK. You know, in the UK, your manager doesn't even need to see you for 3 weeks, but he expects the work to be done. So what I noticed is that stopped people from thinking for themselves. Does it make sense? So because we were so autocratic about the way we led ourselves in a workplace, it stopped people from being creative. Creativity is how we're going to apply some of these things. Yeah. So for instance, if you work in the banking sector, speak to your boss or try and get your boss to implement artificial intelligence to help screen fraudulent activity. You know, AI can be a big combator of fraud in Africa. Things like blockchain could be a big combator of fraud in Nigeria. You know, we can use blockchain to improve land registry. You know, so you can register pieces of land and then not get somebody counterfeiting your claim and trying to sell your land when they don't own the land. Things like that. So we have to be creative. I think what we need to do also is explore. So, you know, go on YouTube, type in practical application of AI, and you're going to find lots of people sharing free information. So if we don't ask questions, we don't receive answers, basically. So yeah, I hope that answered your question. Practical application. You have to be creative and find ways of improving things, making things better, efficient, faster, safer, you know. So
Yeah, thanks very much for that, Josh. Does that answer your question, Bagai?
Yes, it does. Thanks.
Yeah, I think that's something I just want to reiterate, Josh, and this is something that is driven at work as well, is there's this mantra at my place of work that you must use your curiosity and your skills to deliver projects, to deliver your work. And that is very clear in organizations. So you just hit on that curiosity, and I think we need to be curious. One thing I was going to mention, Josh, is there a web link you can share that if people want to self-learn, they want to look more into this, and they can do that in their own time?
hundreds. I'll give you hundreds.
If
Like,
you send that link over
yeah,
to
I'll
me,
send that to you, yeah.
what I'll do is I will share it on our platform, and so that people can go away and in their own time they can upskill themselves or their knowledge in regards to AI.
Yeah, the biggest enemy of progression back home is the lack of electricity, the constant electricity supply. That's the biggest problem. So all you engineers out there that are going to be the leaders of tomorrow, that is what back home needs: constant electricity, constant internet supply. Because once we have that, we can compete with the Western world. Modern computing allows us to be able to compete on an equal playing field now. You don't have to have a massive server. You can use Microsoft's cloud technology and harness the same power that IBM's using. You know, there's no barriers anymore. But when you haven't got constant electricity, constant internet supply, you know, it makes it hard. So
I've got one one quick question then. So are we
sure.
going into a field of AI there? I saw a picture recently where back in the days televisions were big and fat and
Yeah.
humans were slim.
Yeah.
Now there's a contrast to that. Now the humans are now fat and televisions are slim.
Yeah.
So are you saying that now that given that AI is coming to automate so many things, so we're going to start seeing more obesity than human beings, and which becomes more danger to our health?
AI, automation, computing, there's a lot of dangers to it. And the basic reason is, sorry, I'm going to give a religious perspective. We're flawed. We are flawed creatures. So we can only create flawed things. Yeah. As long as there's greed, as long as there's corruption, as long as there's selfishness, anything that a sword is a tool. It could be used for defense or attack, right? So if we create something, it can have positive or negative effects. So yes, AI could cause people to be less active. So therefore, there might be more obese. However, AI could support people with disabilities. So I've seen, and I'll send you a YouTube video of this. There was a young guy. He's a drummer. He plays the drums. So he lost his arm, and they built a robotic arm for him. So he actually printed this arm with a 3D printer. So he printed his own robotic arm, did the circuitry that he learned on the YouTube, and then he paired up with a professor. And what they did is they've got ultrasound to recognize the electrical impulses in his arm, and they built a computer algorithm now that when he thinks to close his hand, the arm closes, it opens up. So now he could play the drums again. Yeah. So there's positive applications, but there's also negative applications. You know, imagine wars without soldiers. You know, generals won't be scared to send robots to go and kill 1,000 people. You know, robots don't care who they're killing, and there's no collateral damage there. So, you know, there's always that positive. We have to create laws and legislation and rules that help us use these technologies ethically. You know, we can't get carried away with being creative. We have to use our common sense and our yeah, you know, we have to use our common sense to manage this stuff. Otherwise, it does cause problems.
Okay, then I think our time is well fast spent anyway, and I really want to thank you, Joshua, for that fantastic talk. If you do share the links, as you've mentioned, send over to me. I will ensure that I share to the group as well. Today has been a very fantastic day. In the morning, we had a lecture on emotional intelligence, you know, as part of our teaching series. And then this evening, the UK chapter is also having this artificial intelligence lecture. So we will, from time to time, or on a monthly basis, we tend to put these up together. And I will be sharing the next lecture series for next month once we get a speaker confirmed. So on behalf of the UK Amana chapter, I want to thank everybody for taking the time to dial in. And I wish you all a very good rest of your evening tonight. And God bless you all. Thank you.
Thank you.
Thank you very much, Joshua. Thank you. Thanks, everybody.
No worries at all. Thank you very much.
Yes.
Thank you.
Have a nice one.
Nice.
Bye then.
Take care.